Hi, this is Dr. Thomas, math instructor at Lawson State Community College, and in this video I'm going to show you how to divide polynomials using long division. Now before you start, you always got to make sure that your terms are in descending order. You're also checking for missing terms, and just remember that you don't need to use long division if you are dividing by a monomial, and a monomial is a single term. So if you have a single term in the denominator, you do not have to use long division. Now long division, and we call it long polynomial division, is very much like regular long division. So let's say we were dividing 6 into 758, for example. Then what we'll do is see how many times does 6 go into 7. That's 1 times, and then we'll multiply this 1 times everything over here, which is 6. That gives us 6. And then what do? We subtract, and we bring down the difference, and then the next thing we do is we bring down the next number, 5. Then we start back over. 6 goes into 15 how many times? 2 times. Then we multiply this 2 times this 6. What do we get? We have 12. What do again? We subtract 3 and bring down the next term. We start back over. 6 goes into 38 how many times? I think it's 6 times because it's 36. Subtract, have 2. There's nothing else to bring down, so we know that 2 is our remainder. So I'm going to show you that polynomial long division is very much like this long division. But let me first discuss what I meant about do not use long division when you're dividing by a monomial, a single term. So let's say you had 9x to the 4th plus 8 or 18x cubed divided by 3x. So notice this is one term, 3x. This is a monomial. When there is a single term here, do not use long division. Use what we've normally been doing. How have we in the past simplified expressions? Well, what we did was we factored the numerator. So let's factor the numerator. What is the GCF? It looks like 9x cubed, and then the remaining factor is x, since 9x cubed times x is 9x to the 4th plus 2. Then we have a 3x at the bottom. Now notice here that we have factors, common factors with 9x cubed and 3x. Therefore, we can start canceling. 3 and 9 have 3 in common. 3 goes in 9 3 times. And 3 goes in 3 1 time. And then this x cubed over x. We can take away 1x from both. Therefore, our answer is we have a 3x squared times x plus 2. So this is how we divide when dividing by a monomial. Another way we could have done this was we could have split the numerator up. Since there's only one term in the bottom, we could have split the numerator up like so, divided by 3x plus 18x cubed divided by 3x. So only if you have a monomial in the denominator. Okay, let's look at it. Let's simplify each of these separately. 3 goes in 9, 3 times, take 1x away. 3 goes into 18, 6 times, take 1x away. So what we have is 3x cubed plus 6x squared. Now, is that the same answer we had before? Yes, it is, because if we distribute what we had before, we would get 3x cubed plus 6x squared. Okay, let's look at 2x squared plus 7x plus 3, and we're going to say divide 2x squared plus 7x plus 3 by x plus 3. Now what this means is you can rewrite it like so. 2x squared plus 7x plus 3 divided by x plus 3. Now we have come across problems like this before. This is simplifying a rational expression. What have we done in the past? What we've done is we've factored the numerator and factored the denominators and see what common factors were there, and we canceled those common factors out. So let's do that. How do we factor this trinomial here? Let's see if we can factor it. Factor 2x squared plus 7x plus 3. So what we've normally been doing, we multiply 2 times 3, we get 6, and we're trying to find factors of 6 that'll give me 7. 1 is 6, gives me 7. Okay, so we'll write all of our terms. 2x squared plus 6x plus 1x plus 3, and then here we can group the first two terms together. We can take out a 2x, x plus 3, plus we already have the x plus 3, so really we can take out a 1. Okay, so our factors are x plus 3 times 2x plus 1. So we'll put our factors up here. X plus 3 times 2x plus 1. So this is equivalent to this. And I bring down my x plus 3. And what do you see? You see common factors. This x plus 3 factor cancels out with this x plus 3 in the denominator. So therefore, the answer is 2x plus 1. Now, the reason that I did that was to show you that you can simplify that expression this way if your numerator is factorable. But I'm going to show you a new way called long polynomial division, where we'll get the same answer, 2x plus 1. And the reason why you need to know how to use long division is because sometimes your numerator is not factorable, but you're still being asked to divide by an expression. So let me show you how to do long division on the same problem. Okay, so this is how you'll set it up. You'll set it up very much like regular long division. If you're dividing by x plus 3, put x plus 3 first. Put this division symbol here and put 2x squared plus 7x plus 3 under the division symbol. You do have to make sure that your terms are in descending order. I saw that it was in descending order already. Descending order meaning that the term with the highest exponent was first, and then the term with the next highest exponent is next, and then the constant is last. Okay? And over here, this is in descending order as well. X to the first power, and then what comes after the x to the first power? The constant. Okay. Let's get started. First thing you do, you look at this very first term here, and you look at this very first term here. And you decide what times x, in this case, is 2x squared. Again, what times x is 2x squared, or what multiplied times x gives you 2x squared. So it turns out that if I multiply x times 2x, it gives me 2x squared. Now normally, and you may not see this everywhere, I normally put the term that I put up here right above the similar term. So for example, I ended up with x to the first power. I normally put it above the term with x to the first power, for example. But that's just a personal preference. I see a lot of instructors place it over the first term here, but it really doesn't matter. Alright, what to do next? Just like in regular division, you will multiply what you just put up in the top, in the quotient, times your divisor. So you're not only going to multiply 2x times x, but you're going to multiply 2x times all of this, x plus 3. What is 2x times x plus 3? So, normally we used to say 2x times x plus 3. And I'm writing this over here so you can see you have to distribute, of course. So what is 2x times x plus 3? It is 2x squared plus 6x. Now, do you remember what the next step is in regular long division? Remember that you're supposed to subtract now. Now, what are you supposed to subtract? You're supposed to subtract all of this, not just 2x squared. You're supposed to subtract everything you just wrote down, not just 2x squared. So I'm going to put a parenthesis around here to show you that don't just change the sign here, but you also need to change the sign here. Okay? So let me take this back up. And show you in red what changes were made. So this becomes a minus sign since I'm subtracting, but I need to distribute that minus sign here as well. So this plus sign becomes a minus as well, because negative times positive is negative. Now we can proceed. Alright, 2x squared minus 2x squared, that cancels. We have 7x minus 6x. That is x. Then do you recall the next step in regular long division? You bring down the next number in regular long division. Here, you're going to bring down the next term and start back over. Now, start back over. We look at the first term here and the first term here, and we decide what times x is x. The easiest of them all. What times x is x? But it's so simple sometimes we don't really think about it. What times x is 1. Positive 1. So put positive 1 here. Then we multiply that 1 times that x plus 3. 1 times x plus 3 is x plus 3. Then don't forget, you must change your signs now. And not just the sign for x, but the sign for 3 as well. So that's negative here, and change that positive to a negative. So we end up having no remainder because x minus x is 0, 3 minus 3 is 0. So the answer is 2x plus 1. The same thing that we got when we simplified that expression. Alright. Let's do another one. Let's divide 3x squared minus 10x minus 4. And you may see this written this way, so just to show you that it's going to be written different ways. So you may see it written this way, and you just need to understand that, okay, if this numerator is factorable, yes, you can factor it. Okay, but you can always use long division to get the same answer. Alright, I wonder if this numerator is factorable. 3 times negative 4, let's see. 3 times negative 4 is negative 12. The factors of negative 12, we got 1 and 12, 2 and 6, 3 and 4. Okay, will any of these numbers give me a negative 10 if I add or subtract them? It doesn't look like it. So already you can see that sometimes you're not going to be able to factor this and get your answer. You're going to have to use long division. Okay, so let's set it up. X minus 4 divided into 3x squared minus 10x minus 4. All of our terms in descending order. We got all of our terms. What I mean about are we missing terms is, let's say we have 3x squared. Let's say we were missing this entire x term here. Then we will be missing the x term. But we have all of them since we have x squared, x to the first, and then a constant. Let's get started. X times what? So we're only looking at this first term here. X times what is 3x squared. So only look at the first terms in each. X times what is 3x squared? What is it? Alright, it is 3x. And again, I usually put it over the term here that's similar to this term that I put up here. Okay. Alright. Then what should I do? You should multiply this 3x here times all of this. So not just x, but you're supposed to multiply 3x times x minus 4. So don't forget that at this point you're multiplying whatever that is in the top times everything on the left. Okay, when we do that, what do we get? We get 3x squared minus 12x. Now what should we do? We should subtract that entire expression we just wrote. So if we subtract this, so I'm going to write this first, put in parentheses. If we subtract this, what happens? You have to distribute, correct? Okay, so just reminding you of that. So once you distribute, let me put this in red. You get a minus here because it was originally positive 3x squared. Now we distributing the negative, and this becomes a positive because negative times negative is positive. Now again, this cancels, and you have negative 10x plus 12x, which is 2x. Then you bring down the next term and you start back over. X times what is 2x? X times what is 2x? It is positive 2. Okay? Positive 2. Then, again, we're going to multiply this 2 times all of that. Alright. What do you get when you multiply 2 times all of that? You get 2x minus 8. And off the back we see that we have a remainder because these are not the same. Then we subtract. That means change all the signs. So minus plus here. That cancels, but we have a negative 4 plus 8, which is positive 4. Positive 4. So how do you write the answer when you have a remainder? Alright. Write the answer as, so we're going to write 3x plus 2 put a plus sign in the middle. Don't forget this plus. Don't forget that plus. Then we usually put our remainder over what we divided by, called the divisor. So it's 3x plus 2 plus 4 over x minus 4. From experience, a lot of students do not put this plus. It should be a plus sign here. If that remainder was negative, most people put a minus sign here and put 4 up here, but I recommend you just put a plus here, and whatever your remainder is, for example, if it was negative, put negative 4 up here, okay? Because you get confused once your remainder has more than one term. And then once you take a negative out, you have to distribute that negative out of all of the terms, and usually y'all forget that. So I recommend you always put a plus here and just put that negative up here if the remainder is negative. Okay, let's do another one. Let's say we had y cubed plus 27 divided by y plus 3. So how would we have done this if I said divide this in the past? In the past, we would have factored y cubed plus 27, because what type of factoring problem is that? It is a sum of cubes. So if you only need that formula to figure out what the factors are for y cubed plus 27. But we're not going to do this this time. I'm going to show you how to use long division on this. Now, we have terms here. Notice, however, we are missing some terms. So do you notice that we are actually missing some terms here? Which terms are we missing? Let's see what we're missing. We have a y cubed. What's supposed to go right behind y cubed is what in descending order? So we're going from highest to lowest. We're missing a y squared term. So when we're missing terms, we add placeholders there, and this is how a placeholder looks. We're going to put plus 0 y squared, because we're missing y squared, but we need something to hold its place. And what this is really saying is 0 times y squared, right? 0 times y squared is 0, so we haven't done anything illegal. What's next? We're missing also a y term, so we're going to put plus 0y. And what comes next? The constant. We have the constant. It's plus 27. Okay. And in the denominator, are we missing any terms? Because if we're missing any terms in the denominator, we're going to also have to provide placeholders. But we're not. We got y to the first, and then we got the constant. So this is how you're going to set it up in long division. Okay, that was pretty ugly there. Do a better job of that. Okay, so we have y cubed, and then we put the placeholders in red again, so you see that we basically inserted those terms in there, sort of like false terms, faux terms. Okay, plus 27, fake terms. Okay, let's start. Again, we start like we normally do. Y times what is y cubed? Okay, it is y squared. Alright, so I'm going to put it over the term with y squared. Just a personal preference, you don't have to do that. Then we multiply y squared times y plus 3. So maybe you, I would say you should maybe pause and see if you get what I get, but since this is a problem with placeholders, you might want to work this with me, and then maybe the next problem see if you can do that one on your own. Alright, let's multiply y squared times y plus 3, y cubed, correct? Plus 3y squared. And then, don't forget, you must change your sign. So minus, change this to a minus. Y cubed minus y cubed cancels. But here, look, let's look at this. We basically have a 0y squared minus 3y squared. So it's really 0 minus 3 that we're concerned about. What is 0 minus 3? It is a negative 3. Alright, negative 3y squared. What do we do next? We bring down the next term plus 0y. Then we start over. Y times what is negative 3y squared? Y times what is negative 3y squared? Alright, definitely a negative sign needs to go here. 3y. Negative 3y times y plus 3 is negative 3y squared minus, because negative 3 times 3 is minus 9y. Don't forget, you must change your signs. So plus plus now, opposite of what we see. This cancels because that's negative 3y squared plus 3y squared. Here we have a 0 plus 9. So 0y plus 9y is 9y. What else? We bring down plus 27. Alright, y times what is 9y? Y times 9, right? Y times 9. So put plus 9 here. And we have 9y plus 27. Don't forget, you must change the sign, so that's minus, and that plus becomes a minus, and guess what? No remainder. Therefore, what we have here, the quotient y squared minus 3y plus 9 is the answer. Now, if you were wondering, when do you know, how do you know to stop? Okay, well, it turns out if the degree here, let me put this in black, if this degree here was lower than this degree over here, That's how you know that you can't continue. But notice that this y is to the first power and this y is to the first power, so you can keep on going. But if this was just a number here, then you can't multiply y times something to get that number, because you're always going to have that y. Alright, let's do one more. Let's say you had to divide x cubed minus x squared minus 9x plus 2 by x squared plus 3x. Okay. So the first thing you do, make sure that all your terms are in descending order. But what I noticed right off the bat is that the divisor is missing a number. Right? It usually has a number, but it doesn't have that number. So I'm going to put a placeholder there. Let's put plus 0. Just a little fake number. Alright, that did not affect the problem. We didn't do anything illegal. X squared plus 3x plus 0 is the same thing as x squared plus 3x. That's how you know you can do it. Alright, and let's use long division. X squared plus 3x plus 0 divided into x cubed minus x squared minus 9x plus 2. So put that in red so that you can see that that was a placeholder. We inserted that fake term there. Okay, let's get started. X squared times what is x cubed? X. Alright. Now we got to multiply this x times everything over here. Okay. So what do you get? We get x cubed plus 3x squared, and let's just put a plus 0x. Okay, let's put plus 0x. Alright, now what to do? Don't forget that you must change signs. So that becomes a minus, this becomes a minus, this becomes a minus. So this cancels. What is negative and what is really here? What's the coefficient here? Coefficient is -1, even though we don't see the 1. It's -1 minus 3. What is -1 minus 3? -4x squared. And what is -9 minus 0? -9x. And then, guess what? We always need to bring down the next term. Plus 2. And we're going to start back over. X squared times what is -4x squared. So notice that this degree, the highest exponent, and this is the same. So we must continue. Okay, we must continue. Now if that was x to the first right here, then stop, because that's your remainder. But since it's the same, we got to keep on going. Alright, x squared times what is -4x squared? It's -4. Alright, erase this. What is -4 times all of this over here? It is -4x squared minus 12x minus 0. Don't forget, you must change all your signs. This cancels, and you have 3x, and you bring down your 2. So this is the remainder here. This is your remainder. So write the answer. How would you write this answer? Alright, so it's always the quotient. This is the quotient here. So x minus 4. Then what do I say? Put right after that quotient, put a plus. Okay. Please insert the plus sign. Then you're going to put your remainder over here. Okay, your remainder, 3x plus 2 divided by your divisor. And you can use your original divisor, x squared plus 3x. So this is how you would write your answer. Alright, this concludes the video on long division. I believe it's going to help you.